In this video 3-6, we will be working with compound inequalities. By the end of the video and work time in class, you should be able to say, I can solve and graph compound inequalities. A compound inequality consists of two distinct inequalities joined by the word and or the word or. So we're working with and or as those as we look at these compound inequalities. For example, if we had a solution that x is greater than or equal to 3 and x is less than or equal to 7, when we graph this, if we have 0, let's say right here, 3 and 7, and x is greater than or equal to 3, so we would have a closed circle at 3, and that would be shaded to the right because anything greater than that. But then it says x is less than or equal to 7, so we would have a closed circle at 7, and it would be shaded to the left of that because less than that would be to the left. So this is the type of inequality when it's and. Another way to write the answer would be x is greater than or equal to 3 and less than or equal to 7. But what I've noticed too is with these types of compound inequalities, I usually don't say and, I usually say but, where I would say x is greater than or equal to 3 but less than or equal to 7. The other type of compound inequality, we use the or. And so an example here, let's say we had x is less than negative 2 or x is greater than or equal to 1. So let's say I have 0 here and negative 2 is located to the left. If x is less than negative 2, it's open, shaded to the left, to the arrow. If I had x is greater than or equal to 1, I would have 1 here. It'd be a closed circle, shaded to the right. And so this is what an or would look like, where it's split and it's going in both directions. What compound inequality represents each given phrase? All real numbers that are greater than 1 and less than 5. So we have all real numbers that are greater than 1 and less than 5. I could also say all real numbers x, such as it's greater than 1 but less than 5. All real numbers that are less than 10 or greater than 15. So for this one we would say all real numbers x that are less than 10 or all real numbers that are greater than 15. Notice with the and, the compound is written with one variable in the middle. The or has two separate inequalities with the or in the middle of those two. What are the solutions if negative 2 is less than x plus 2 is less than or equal to 5? So what we want to do here is we want to get the x alone in the middle of this compound inequality. So to do that, we're going to subtract 2 because the opposite of adding 2 is subtract 2. And what we do is we subtract 2 from every side. So we subtract from the right side and we also subtract 2 from the left side. And what happens is we're with negative 4 here. X is now alone because that simplifies to 0. So how we would say this is x is greater than negative 4 but less than or equal to 3. So here's our solution. It is an and. We should already know what the graph of an and compound inequality looks like, where it's part of the line. Remember, or splits off and goes in both directions. So I'm going to put 0 here in the middle. I'm going to say negative 4 here is to the left. X is greater than that, can't equal it, greater than that, but less than or equal. So this one's going to be closed. Less than or equal to 3, and then it's shaded in between there. So every solution is shaded. To win the recycling contest, you must collect between 83 and 87 pop tabs each week, inclusive. So that means you would include 83 and 87. Suppose you collected 82, 86, and 84 pop tabs during the first 3 weeks of the competition. What are the possible numbers of pop tabs you could collect during the 4th and final week in order to win that recycling contest? So you would want to win, or I'm sorry, it said collect between 83 and 87 pop tabs. So we have to have something greater than or equal to that because it's inclusive, but less than or equal to 87. So somewhere between there. So we're going to average out what we have. We know that we have 82 plus 86 the second week, plus 84 the third week, plus x, which is the 4th week. We're dividing that by 4, and so our average is going to be between 83 and 87. So the first thing we want to get rid of to get the x alone in the middle here is we want to get rid of dividing by 4. So what we're going to do is we're going to multiply everything by 4. So in the middle by 4, on the left side by 4, and on the right side by 4. So then we're left with 332 is less than or equal to, and I'm just going to add 82, 86, and 84 together, and you get 252 plus x is less than or equal to 87 times 4, which is 348. Now to get the x alone in the middle, we're going to subtract 252. We subtract here from the left, and we subtract it from the right. So that is simplified to x's alone now. So when we do 332 minus 252, we're left with 80. And 348 minus 252, we're left with 96. So the possible numbers of pop tabs that you could collect that 4th week would be between 80 and 96. What are the solutions to 2n minus 1 is less than negative 3, or, so this is going to be an or graph, negative 3n plus 2 is less than negative 4. So we have 2n minus 1 is less than negative 3, so we're going to add 1 to both sides. And then we're going to divide by 2. So n is less than negative 1. But we also have negative 3n plus 2 is less than negative 4. We have to reverse the sign. So our answer here, n is less than negative 1 or n is greater than 2. So here's 0, here's negative 1. N can be less than that, or n can be greater than 2. Notice they're open circles. This is an OR graph where it's split and going in both directions. Interval notation includes the use of 3 very special symbols. We're going to be dealing with parentheses, brackets, which look like this, and also infinity, which looks like an 8 but written horizontally. And so I'm going to show you how the interval notation is used. I'm using 4 different inequalities here. So I'm going to write the inequality on the left side. X is greater than or equal to 2. X is less than 2. X is greater than 1 but less than or equal to 5. So we have compound. X is less than negative 3, or x is greater than or equal to 4. So the bottom 2 are compound. And so now, in a different color, I'm going to graph them. So x is greater than or equal to 2, can equal 2 and anything to the right. x is less than 2 would be open, shaded to the left. So we'll say that we have 1 and 5, and x is greater than 1, but less than or equal to 5, shaded between there. And then we have -3 involved here, and we have a 4 over here. X is less than -3, so open, shaded left. Or x is greater than or equal to 4, close, shaded right. Alright, so we have our inequalities, we have our graph, so at this point it's been review. Now we're going to look at what interval notation would look like. With interval notation, a bracket means that the endpoint is included. So 2 is included because it is closed. So if 2 is included, I'm going to use a bracket. I'm going to write 2, comma, and then after the 2, since it's shaded to the right, to the arrow, that's infinity in the positive direction. And then with infinity, we put a bracket, or I'm sorry, a parenthesis. In number 2, we have infinity in the negative direction. So with infinity, we always use a parenthesis. So I write negative and then infinity, comma, 2. So it goes to 2, but 2 is not a solution because it's open. So that's a parenthesis. Let's see in the compound between 1 and 5, where 5 is included, but 1 isn't. So a parenthesis because 1 is not included, and then 5 with a bracket because the 5 is included since it is shaded. And then with the OR compound inequality, negative infinity, remember we use a parenthesis with infinity, and that goes to -3, and that would have a parenthesis because it's open. And then we write OR, and we have a brace, this should be a brace, 4, and then to infinity with a parenthesis. So here you can see our inequalities and compare that with the graphs, and then you can compare that to the interval notation that uses parentheses, and that parentheses means the endpoints are not included. The brackets means the endpoints are included, and then we have infinity, which we can have infinity in the positive direction and then in the negative direction as well. Can you say I can solve and graph compound inequalities? Write a summary reflection and be prepared with any questions for the work time in class.